Okay, so here is a Chapter 6 review. Make sure that you try these problems on your own first because you want to see if you can do them and then double check your work with my video, okay? So don't just sit here and copy down what I'm doing. You really want to put thought into it and see if you know what these problems need you to do. So here for the first one, we are asked to solve each equation. So in other words, that means to solve for x. Okay, so if I have 5 times 3x minus 4 equals negative 95, let's go and draw our line down the equal sign. Now I'm going to move relatively quickly because this is a video and you have the ability to pause. So make sure that you are pausing throughout the video to grasp the concepts and make sure that you do understand what I'm doing. So the first step is to distribute this 5. Now, you could have also divided both sides by 5 to undo the 5 on the left. It would look like this. So if I were to instead do that, then I would end up with 3x minus 4 equals, this would be 19, negative 19. So that's another way you could also do that. You just have to be careful because you have to make sure that, like some students, they would divide like both of these pieces, but that's not correct, right? It has to be this whole entire thing is a product, so you divide it by whatever it's being multiplied by, and then you could also solve it that way. What most of you are familiar with is distributing the 5 into the parentheses, and that works just fine as well. So 5 times 3x is 15x. 5 times negative 4 is negative 20. It's equal to negative 95. Okay, so here I'm going to add 20 to both sides. So this is where I would want you to stop, and I guess I should have said, okay, what is our next step, but try to pause frequently after each step I do to see if you can do it on your own first, because you're the one who's taking the test, not me, okay? So now we'll do 15x equals negative 95 plus 20 is negative 75. Divide both sides by 15. You should get x equals negative 5. Be really careful with these negatives. A lot of students forget the negatives and then they end up with the wrong answer. But luckily, looking here, our answer is A. Now, you can also check your solutions whenever you're solving for problems like this. So my original equation is 5 times 3x minus 4 equals negative 95. So I want to plug in, instead of x here, I want to put the negative 5 and see if whatever I simplify here ends up being negative 95. So here I have 5 times 3 times negative 5 is negative 15 minus 4, 5 times negative 19. And I would highly recommend that you always have your Desmos calculator open and ready for you. It's the scientific calculator. I can do a lot of the stuff in my head, but I always want you guys to check your work here, okay? So here, if I were to do, I think it's, let's see, 5 times negative 19. And don't mind my yawns, it's super late right now. I'm just trying to get everything ready before I leave. All right, 5 times negative 19 is negative 95, so we are good. That does equal negative 95. Okay, so that's another way to check to see if negative 5 is the correct solution. In this case, it is. Okay, so I want you to solve number 2 on your own. You got it. Okay, give it a shot. You can check your answer on the very last page. Now, you have to show all of your work in order to get credit because you can check your answers. I would never give you work and you not be able to check your answers eventually or right then and there because it's good for you to check your work to see if you actually know what you're doing. Please don't hesitate to ask the sub for any help, but you guys should be good to go, okay? So solve that one. I'll go ahead and do number 3. Maybe I'll just do all the odds. I think I'll do all the odd numbers. So we have 240 equals negative 5 times negative 8x minus 8. Okay, so you always want to make sure that you double check that you wrote it very carefully and you wrote the whole thing correct. I see a lot of students get problems wrong just because they wrote this wrong. Okay, so make sure whenever you're copying down on your paper or your Cami that you're very careful. So this time, I guess I'll show you guys both ways, like how you could start off this problem. Okay, so there's two different ways you could go about this. You could either distribute the -5, which many of you are familiar with. So -5 times -8x is positive 40x. -5 times -8 is positive 40. And that is equal to 240. I wonder if you guys can hear Macy snoring. She's leaning against me, snoring pretty loud. Okay, so if we divide both sides by -5 here, that would eliminate the -5 on the right, because this is a product. -5 times this in parentheses, that's a product. So to undo multiplication, you divide, right? So here, 240 divided by -5, let's see here. I get -48, okay? She's out. -48 equals -8x minus 8. Okay, so let's see if we end up getting the same thing, okay? So I'll go ahead and solve the rest of this side. So if I subtract 40 from both sides, hi Mace. Okay, so we're going to end up with 240 minus 40 is 200 equals 40x. Divide both sides by the 40. You should get x equals, these cancel out, 20 divided by 4 is 5. Right, so let's see if we get 5 on the other one as well. So here we want to add 8 to both sides. -48 plus 8 is -40 equals -8x. And these two cancel out to 0. So now your last step is to divide both sides by -8. So here we have 5 equals x. These are the same thing. So you could check your answer just like we did before, but I trust that this is my answer. I solved it 2 different ways and I got the same thing. So number 3 is B. And again, please remember to take notes and to show all of your work, especially for like these that I don't do, still show all of your work, because you could just grab the answer from the very end of the document, but then you won't learn anything, right? You won't know how to do them. So please make sure that you are putting in the effort to practice these and kind of mirror my steps if you're struggling. So number 4, go ahead and do it on your own. You can do it. All right, now we're getting into transformation. So I just want to jot down a few notes. We'll do it off to the side here. So transformations. Let's just review. You can write this down in a notebook, piece of paper, whatever you have, okay? So there's some that are rigid, which means size and shape stay the same. So one of those is a translation. We slide, basically, is what a translation is. Okay, so we slide either, so the x values, this would be like left or right if it's minus or plus, and then some number, right? And then y, and then this would be, let me write this all together here. And then y is up and down, minus goes down, plus goes up. So it would be like +2 or -3, right? So that would mean you go to the right 2 and down 3, okay? So translation means you are sliding, right? So here, I'll put this in a different color. So let's say we go +2 down 3. So this would mean you go to the right 2 and down 3 from your original, whatever your original shape was there. So that is a translation. Okay, I don't really like that. Was a horrible little rectangle there. Nice. There we go. All right. So now another one that is rigid would be a reflection. So reflection is a flip. Okay, so you flip over some line of reflection. So you must have a line of reflection. Okay, so here, I'll go ahead and draw a line. Let's see here. And then I'll draw a fake little triangle here. Call it A, B, C. Okay, and then let's see here if I can duplicate this. And then, oh, not quite. This is rotation here. But I cannot flip it. I wonder if there's a way to mirror it. I don't think so. I'll just have to try to sketch it out the best I can. So the mirrored shape would be something kind of like this. If I had a grid, I could actually count them out perfectly, but this is what it would look like. You see, those are primed, so that's the new shape. So that was the reflection of the original shape there. Okay. All right, so that's reflection, and then we have a rotation. Okay, so a rotation, basically you're turning a shape. Okay, so you have to have a point of rotation and degrees and direction. So you remember the Khan Academy is a little bit difficult. I use clockwise, which would be this way, and counterclockwise, which would be that way. Okay, Khan Academy said clockwise was negative, counterclockwise was positive. All right, so it's kind of like tipsy-turny there. But that just means we're turning a shape. So if I were to have some triangle here, if I were to have some triangle, I can rotate here with my little shape here, but we'll practice more rotations during this practice, okay? So that is a rotation. Let me go ahead and move some of this stuff. Move this back up. All right, so that is a rotation. So that is another rigid one. The only non-rigid transformation is a dilation because the size does change. Okay, so the only non-rigid, rigid means it stays the exact same. Non-rigid transformation is a dilation. Okay, so shape gets bigger or smaller. Sorry, my handwriting's super sloppy tonight. So the scale factor is super important. We use the letter K for scale factor, and that is new over original. So if you have a new length over the original length, that would give you the scale factor of the dilation. Okay? All right, so let's go ahead and take a look here. Write a rule to describe each transformation. So the first thing you want to look for is, okay, which one was the original shape? Well, I see here G, H, I, J. Those do not have primes. So it looks like we went from G, H, I, J to the one with the primes, which would be G prime, H prime, I prime, and J prime. Okay, so here we have the original. You guys can probably hear her snoring. The original or the old is what some students call it, and then the new shape is right there. So what is this? Is it a reflection, translation, dilation, or rotation? Well, this shape, the new shape, is definitely not the same size, right? So the only option here is that it is a dilation. 1.5 would mean it does get bigger, okay? So this one makes sense. If my scale factor is greater than 1, it gets bigger. 1.5 is bigger than 1. So if k equals 1.5, new shape is bigger, okay? And that's definitely true here. We have this blue shape here. It's definitely bigger than the original one. All right, so that one would be B. So make sure to pause if you need to like either take a picture of these photos or of these notes or jot them down yourself. Take some time to do that, okay? All right, number 6. So make sure you are trying all of these on your own. I'm going to go through as many as I can. So here, look at this line. This line is right in between those two triangles. So first of all, you kind of want to look at how they're oriented, right? So some students might see this and instantly say rotation, but I'm going to show you what happens if this were to be an actual rotation. So, oh wait, no, I'm going to draw my original triangle. I wonder if that would turn it. Yeah, cool. All right, so this is my triangle, right? And then I had C, D, and B. All right, so this is the original one because this one does not have the primes. So it looks like we went from B, C, D to B prime, C prime, D prime. Okay, so here, if I were to grab, including the letters, because I want to show you how they rotate, and if I were to rotate them, if people are like, oh yeah, it's rotated, you know. So if I were to rotate it and have it in this area, look at what happens. Okay, I know my letters are upside down, but you see how the C is now next to the D prime, and the D is now next to the C prime? And look, it's a totally different shape here. Okay, so this would be a rotation 90 degrees counterclockwise around the origin. That would be a rotation, okay? Or actually, around the origin would be a little bit out, just a little bit more. It'd be a little bit different, okay? It'd be somewhere, yeah. Yeah, it would be about there, okay? So that one's a lot, it's different, right? So here, now you're like, okay, well, I also notice B is 1 unit away from the line, the y-axis. So is B prime. And look here, D prime and D are lined up right here. And D prime is 1, 2, 3, 4, 5 units away. And D is 1, 2, 3, 4, 5 units away. And I just marked this yellow line here because I was like, oh, that looks like it's right in the middle. Like I kind of was just taking a guess. So this one is a reflection across the y-axis. All right, so whenever you have a reflection, you have your original point and your new point lined up. C is the original point. C is 1, 2, 3, 4, 5 away from the line of reflection. C prime is also 1, 2, 3, 4, 5 away from the line of reflection. Okay, so this is definitely a reflection. Also, if you wanted to test if something was a rotation or not, you see how the only rotation option here is clockwise. So clockwise means that this shape right here, that original shape would go clockwise. This is clockwise, like how a clock, its hands go around the clock, it's going towards the right, that's how it turns. So it's definitely not going clockwise, right? If this were to even be close to rotation, it would be counterclockwise because we ended up over there. If it was clockwise, it would have to move 270 degrees to even get back up into that quadrant. Okay, but with 90 degrees clockwise, it would end up somewhere in this one, and that's not where our new shape is. So you could have read that and crossed that one out. A dilation of 1/4 means that the new shape is smaller. It is not. Okay, and a dilation of 0.5 also means it's smaller. It is not, right? It's still the same size, exact same size. So this answer is C. Alrighty, so let's look here. I do like to look at my options. So we have translation. Sorry guys, I'm yawning. We have translation, rotation, dilation, and reflection. Well, a reflection across the y-axis. Let's look at this here. This is the y-axis. If I reflected my original, or what I call my old shape, across the y-axis, P is 2 away from the line, so P prime would be 2 on the other side. Q would end up here, Q prime, and then R would end up here, R prime. So this would be the reflection, and that's definitely not what this blue one is, right? So I know it's not a reflection. So I can cross out D. Now a dilation means it's going to become 1/4 the size of what it is, and if it's about the origin, it means that it would be somewhere in this area. It would be somewhere in between the origin and the dilation, or the original there. Because if it is a smaller, so 0.25 is less than 1, so that means the new shape would get smaller, so it would get closer to the point of rotation. In this case, it's not getting over there, right? It's on the complete other side of the grid. So now we have a translation or a rotation. So what I would try to do is try out the translation and see if it works. So the translation says 7 units left and 5 units down. You always have to start with the old. So let's go ahead and move point P. We'll go 1, 2, 3, 4, 5, 6, 7. Yep, that was 7 units left. 1, 2, 3, 4, 5. 5 units down, I did end up there. Let's do it for every point though, okay? So I'm gonna go, Macy just left me. I think she's tired of me making this video. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yep, I ended up at Q prime. So now let's try R. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yep, R prime. This is a translation. Another way to see that it's not a rotation is that if it was a rotation, your vertices here would not be oriented the same way. They would be almost flipped, okay? So you want to make sure, keep that in mind with rotations, is that your vertices are going to move around the triangle, or your shape is literally going to turn, right? It's not going to be the same orientation. Where right now P is on the left for both of them, and then Q's are on the top right, and then R's are on the bottom right, right? They only stay the same because it's not a rotation. Okay, so that one's A. This one, okay, so let's look at this. It says, okay, we have a few options here. This one is tricky. I will tell you that much. This one is definitely tricky. Okay, so first of all, you want to kind of look at how it's oriented. Okay. First things first, if we look at D, D is a dilation. If it was a dilation, if the triangle was like this, the new triangle is going to be oriented in the exact same way, just a different shape. Or I'm sorry, just a different size, right? So dilations, they stay the same shape and they stay the same orientation. They just get bigger or smaller. So this is not a dilation. Okay, this thing's all turned and crazy. We're not sure what's going on here. So I just want to emphasize again that this one here is my original, the black one. Okay, this is my original. And it is K L, M, N. So I want to make a copy of this and kind of just play around a little bit. So here, I want to see if it could be a rotation, okay? So let's see here. If I were to turn like so, you guys see here, okay, so so it looks like I need to go just a little bit more to get, you see here how I'm having some trouble? I'm trying to line up this one with the blue one. So the shape here, like there's the N, but like nothing else is lining up for me here. So I rotated it 180 degrees, right? So watch here. If I were to make a little grid, let's say this is the center, okay? And this is my XY grid. This is how I normally teach it in person with tracing paper, so it's really difficult. But one turn to the right would be a 90-degree turn, okay? So I'm going to move this out of the way just a little bit, and I'm going to show you a 90-degree turn. So I'm going to turn one turn to the right. Bam, that's 90 degrees. Okay, that would be 90 degrees from my original. Now, if I go again, one more turn, and these are all going clockwise, by the way. If I go one more turn here, okay, I'm going to end up, let's see here. Whoopsie, I lost my K. That's always frustrating. I wish I could like see everything is selected. Okay, so one more turn. So this one would be 180 degrees. All right, so this one here is 90 degrees clockwise, and this is what question A is asking us. Is it 90 degrees clockwise? This is what 90 degrees clockwise would look like. This is how my blue shape would be oriented. It is not oriented that way. Do you guys see that? The blue shape, this is what the blue shape should be, and it is not oriented correctly, not at all. So I'm going to go back to my original black shape here, okay? And instead, this time, we're going to test out, because we know it's not A, so we're going to test out 90 degrees counterclockwise about the origin. So I'm going to take this one more time, and we're going to go 90 degrees counterclockwise, which means to the left. So counterclockwise, I'm going to go this way, and that's 90 degrees. It's really easy because I see a rectangle, so it really helps. And now you see here too, this does not line up with the blue one no matter where I put it. It is not going to line up with it. This is definitely not a rotation. Not a rotation. Okay? So now what I want to focus on is, okay, then how is it a reflection? You want to make sure that it makes sense to you. So here, if I were to draw my line of reflection where it says at the x-axis. So this is the x-axis here. So with reflections, let's go and start with M. M is 2 units away from the line of reflection. So M prime should also be along the same line, 2 units away. And it sure is. Okay? So you can definitely reflect a shape over itself. They can overlap. That's totally fine. It just gets a little bit trickier. So now N, the original N, is down below here. It's 3 away from the line of reflection. And N prime is also 3 away from the line of reflection. So that's good. That is a reflection right there of the point N. Now the point L up top right. We are 1, 2, 3 away from the line of reflection. And also 1, 2, 3 away from L prime, which is the image of L. So L was reflected across the x-axis. And then last but not least, we have K is 1 unit away, and so is K prime. So this is definitely C as the answer. Okay, I'm going to let you guys do this one. Okay, this one, look at number 8. Actually, I don't want to write that there. You guys can do that one. Okay, so I'm going to kind of start picking and choosing here, and then you can always check your answers at the end, but you must show all work. There's always work that could be shown. Just like I did above, I was testing the problems and whatnot. So make sure that you show all of your work. I think you can do that one. This one's a little bit more difficult. So looking at this one, is it a reflection across the x-axis? So a reflection across the x-axis would look something like this. If I had an x-axis here and I were to reflect h across, h prime would be right here. J prime would be right here. So it would be like a direct reflection here. Let's see here. 1, 2, 3, 4. 1, 2, 3, 4. So this is what a reflection across the x-axis would look like. That's what it would look like. This is definitely not a reflection. Okay? Not a reflection here. Not A. All right, so translation, 8 units to the right and 2 units up. Okay, so let's try to move point J. Because remember, guys, I'm always starting off with the black one here because that is my old, and then the blue one is my new because it has the prime. Okay, so I wish there were more distinct colors like green, orange, right? Very distinct colors. But blue and black, okay, represent our old and new. All right, so for I, we're going to test C. Okay, so we're going to move point I 8 units to the right, 5, 6, 7, 8, and 2 units up. Is that where I should be, or I prime? It's not, right? I prime should be here if I were to actually do the correct translation or the correct transformation to my new shape. So it is definitely not translation either. So really this stuff is a good process of elimination. Okay, it's definitely not translation. A rotation. First, I want to look at dilation and show you guys more about the concept of eliminating answers. Dilation of 1/4 about the origin. So that means that the distance away from the origin is where those lines are where my new shape should become. And honestly, like this one would be super duper tiny. Like so ridiculously tiny here. Okay? And it would go towards the origin because it is smaller than 1. So this will make my old shape smaller. Okay? So my image would be smaller than the original. This is definitely not a dilation because this is where it would need to be, right? So that is not working. So our last bet is rotation. So rotation 90 degrees clockwise about the origin. So I'm trying to think if there's a way I can do this. Let's give it a shot. So I'm going to make it a different, brighter color here. So I'm going to go ahead and draw. There we have G, H, I, J. And what I'm going to try to do is like get almost a perfect square, almost have it, to where I can actually rotate about the origin like that. So normally we would hold a pencil in the middle at 0, 0, but this we'll have to do. It might be a little bit off, but I'll try to adjust it. So this one says rotate 90 degrees counterclockwise about the origin. Counterclockwise means going this way. 90 degrees means one turn until I'm flat again, basically. Okay, so let me go ahead and try here. See if we can rotate a few things. That question mark is going to come with us, but it's just going to have to happen because I'm not going to do this again. All right, so 90 degrees, I have to go one full turn to the left there. This is definitely rotation 90 degrees counterclockwise about the origin. So I made my square a lot bigger just because this would help me rotate about the actual origin instead of just rotating about the shape itself, right? So hopefully this kind of helps you see how a rotation would go. And I wish we could use patty paper. It's like a transfer paper It's kind of like tissue paper, but thicker. If you have any at home, or like baking paper or anything like that, parchment paper that you can see through, I highly recommend you use it to help you out with rotations. Okay, but this one is B. Alrighty, I think I'm gonna let you guys do those. Okay, so this one, you definitely want to draw on the graph before you select your answers, okay? You want to do what this says. So this one says move 1 unit left and 1 unit down. So every single point, you're going to move 1 unit left, 1 unit down, and then label it. So this one would be D prime. For the E, I'm going to go 1 unit left, 1 unit down. This one is E prime. And as you go, you can erase the jumps. Oops, I didn't realize that jump was attached. You can erase the jumps, it's totally fine if it's less messy for you. So go over 1, down 1, and this is F prime. And then for C, go over, let's see here, go left 1, down 1. Okay. This will be, oh, that's a C, not a G, sorry. C prime. Okay. So again, I'm going to go ahead and erase my little jumps and whatnot, just because I like it to look a lot cleaner. So I'm going to sketch my new shape if I did that translation that was stated in the directions. So now I'm going to look to see which one has the correct graph. So first I'm just going to focus on like one of these. So I'm going to focus on F prime. F prime, F prime, F prime, F prime. So on my graph here, I'm going to jot down where F prime is. So F prime from the origin is 1, 2, 3, 3 to the left it looks like. 3 to the left here. So that is a -3. And then we're down 1 from the x-axis. So it'd be -1. So -3, -1 is the point for F prime. So you want to look to see, okay, which of these is -3, -1? Well, this one is -3, +1. So it's not that guy. This one is -3, 0. It's not that one. This one is -3, -1. And then this one would be this one is actually -2, -2. So that one's incorrect. It is C. And if you had more than one correct, then you would just want to plot more points or compare more points, right? So here, you can do that. You can pick like the E point here, or the E prime point. So this point would be 1, 2, 3, 4. So -4, 1. And then you can use that point to check it instead. Okay? I feel like I'm starting to fall asleep. I kind of feel like I'm sleep talking. This one's another translation. Okay? Translation. So if it says something like x, y, and then something x, y plus 1, this just means, with just x there, it just means do not move left or right. And same thing, if it was just a y, it would say do not move up or down. So do not move left or right, but it does want you to move up 1 unit. Okay? So here, you do not want to move this one left or right at all. You just want to move each of these up by 1. And then replot your triangle there. Okay? You can do that one. I believe in you. So this one, x plus 6, means we're going to the right 6. Y plus 5 means up 5. So go ahead and give that a shot for each of those points there. Reflection across the x-axis. So I'll help you get started, but then you need to do the rest. So here, we'll do A first. A is 1 unit away from the line of reflection. So A prime must also be along the same line 1 unit away from the line of reflection. Same thing for B. If B is 3 away from the line of reflection, B prime must be 3 away from the line of reflection. And you could keep on going and then connect the rest of your triangle. So see what you get for number 17. Do the rest of it on your own, okay? There's another reflection, except this time it is across the x-axis. So same exact idea, you're just going up and down now rather than left to right. All right, I don't believe we'll see too many rotations besides, excuse my yawn. So here I'm just going to show you a little trick. So this one says 90 degrees clockwise. So that means, again, if I'm in a grid, it just turns one grid to the right. So like my x will now end up somewhere over here, x prime. My w is going to end up right here on the x-axis because it was on the y-axis. The v will end up right here. And the y, if I were to rotate this, it's going to end up somewhere up here, y prime. Okay? So with rotations, you could imagine it's way easier with tracing paper. I totally understand that. All right, so I want you guys to go ahead and look there and see if you can figure out which one of these the answer is. There's another rotation, except this time it is counterclockwise, 90 degrees. Make sure that you are using Khan Academy videos, YouTube videos to help you out with rotations. Another one. Okay, dilation. So if we're going from the origin, okay, and my dilation is 2. So this one looks like I'm going to the right 2 and up 2. But if my dilation is 2, I'm going to multiply each of those by 2. So 2 times 2 is 4. So I'm going to go to the right 4 and then up 4. Okay. So now this here is my new y prime. So I can do the same thing over here. So from the origin to one of my points, x, so I go to the left one, and then up 2. Okay. So now for the dilation, I need to be 2 times away from that. So I'm going to go to the left 2 times instead of just 1 time. And instead of going up 2 times, I'm going to go up 4 times because 2 times 2 is 4. Okay, and this is going to be your, where did I start there? Oh, from the origin. Yeah, so that is going to be my x prime. Okay, x prime. All right. And then last one, if you want to see it, so I'm going to go and erase little bits and pieces here. Okay, so here, I don't really know what all those scribbles are. Oh yeah, they were the rest of it. Okay, so, oh, why did I erase all those? That's what those were. I'm so tired, guys. Okay, last one probably. All right, so now the W, dilation of 2, so here's the origin. The W is 1 down and 1 to the left. So, in order to do the dilation of 2, I need to go 2 down, because 1 times 2 is 2, and 2 to the left. And there is W prime. Okay? So now I can actually sketch my dilated shape of this triangle. And it's done. Okay, so now you'll look carefully at your answer choices. There's really only one that matches up here. You can also look at like where it crosses the y-axis. This one crosses it at 4, whereas this one crosses it down here at 1, 2, 3, 4, 5. And this one here, 1, 2, 3, 4. So I definitely stick with the 4. Okay, so the answer is A. C is smaller and so is B, so we know it's not either of those. Dilation of 3 about the origin, same idea. Dilation of 2. Here's another thing you guys want to do is actually identify like what transformation is happening here. Okay, so here it looks like a rotation for sure. All right, so you see how we start at F and then we go to F prime. So to go from F to F prime up top in a 90-degree rotation, is it clockwise or counterclockwise? I'm going up to the left. It'll be counterclockwise. Definitely not a translation, definitely not a reflection. Okay? That one's definitely a dilation. The blue one's a lot bigger. This one, I want you to try to figure out. It's relatively simple once you get the hang of it. This one, I can see what it is. Okay. So find the coordinates of the vertices of each figure after the given transformation. So if we're given y is -1, -1, x is -1, 0, w is 2, 2, and v is 0, -1. Okay? If there is a dilation of 2 about the origin, then you can just multiply every single one of these parts of coordinates here by that 2. Gosh, I hope that whatever I'm saying is making sense because I feel like I'm talking gibberish right now. I'm half asleep. All right, so now the new one, y prime, would be -2, -2 once you multiply them together. X prime, -2, 0. W prime, it would be 2 times 2, 2, 4, 4. Okay, and then v prime, instead of 0, -1, we're going to have 0, -2. Okay, so that is how you would dilate it. So now you have to go ahead and match it with A, B, C, or D. Now it looks like the first 3, all the y primes are decimals, right? But look at here. So y prime, -2, -2, perfect. X prime, -2, 0, awesome. W prime, 4, 4. V prime, 0, -2. At first I thought it said 0, -2. 0, -2. Okay, so that's how you would do those. You would just multiply them by the scale factor, and then you're good to go. Okay? So these here, what you would do is multiply. So you could either multiply it by a fourth or by 0.25. They're the exact same thing. They are equivalent. So most students like to do it by 0.25. Okay, so here are the answer choices. So you'll see like number 1 is A, number 2 is B, number 3 was B, number 4 B, and so on. Okay, so make sure that you check your work for these, and let your, if you have a tutor on campus, let your tutor know that you need help. You guys do have my sub. He's awesome. He's super